Dear friends, it brings me great joy to welcome you into the realm of neural networks and deep learning, the branch of AI that enables machines to emulate the brain's natural ability to spot patterns. Because neural networks unlock extraordinary creative capabilities across both vision and language, I find that their spirit is beautifully echoed in the literature of neuroscience, identity expansion, and the psychology of self-concept. In our last episodes, we covered a brief intro into identity shift, while also covering tactics to regulate our nervous system in order to prepare for a new identity. Well, this video gets us to the immense power of neuroplasticity as the background force we need to create our new selves. As Michael Merzenich, the father of neuroplasticity, points out, our old identity is a heavily used map. To shift identity, we must interrupt old patterns, use new ones deliberately, repeat them consistently, and add positive emotional charge. Attention and choice can rewrite compulsive or automatic patterns, as demonstrated by Jeffrey Schwartz, who points out how noticing, reframing, and reassigning meaning actually rewires the prefrontal cortex and reduces the grip of old identities. Here is the roadmap we will explore together when it comes to neural networks and deep learning. As usual, self-development will be our trusted companion along the way. 1. Preparing the data. 2. Building the model. 3. Setting the loss function and optimizer. 4. Training. 5. Validation. 6. Saving the model. 7. Loading the model for inference. 8. Deploying or integrating the results. We begin by gathering our data. You may choose to rely on a dataset that already exists, or design one of your own. If the dataset already exists, we pay close attention to key arguments. Root tells PyTorch where the dataset is stored. What areas of our life does our new self touch? Do we focus on our career, our relationships? Train equals true or false decides whether this portion is for training or testing. Think of the vision we have of our new self and how life challenges us to add new touches to the sketch we made. Download specifies whether PyTorch should retrieve the dataset from online sources if missing locally. Transform/target transform applies modifications to features and labels. Features are the inputs used to make predictions, while labels are the outputs or answers the model is trained to predict. Receptivity to novelty is a feature, the willingness to make the first step and introduce yourself to a room you don't know. A soul is a label. Transforms. In practical scenarios, especially with image data, we usually work with transforms.compose open bracket, open parenthesis, close bracket, a pipeline that applies multiple transformations in sequence. If the new self is a goal-getter, your pipeline starts with discipline to declutter distractions, keeping a routine as boring as it may sound, training your observation skills to detect opportunities, and openness to experiences which your old self perceived as uncomfortable. Normalization, which rescales images or activations into a uniform, stable range. Neuroplasticity is reshaping your brain to new habits. Start with dipping your tiptoes in the ocean and go for what your old self was least scared of. It rescales your entire perspective over your abilities. Data augmentation, used during training to introduce new variations and increase robustness, like accustoming our brain to be comfortable with new experiences within the same spectrum. Let's say we go for public speaking. We start with a toast amongst friends. We move to asking questions to a panel. We practice within communication workshops. And soon we'll be taking on an open mic challenge. Data loaders, batching and shuffling. Once the dataset is ready, we pass it into PyTorch's data loader, which handles batching, shuffling, and parallel loading. We launch our deep learning project by selecting the device where all operations will run. PyTorch must know whether tensors and models reside on the CPU or GPU. Mixing them causes errors. Our options include CPU, the default processor on most machines' GPU, dramatically faster for deep learning. In neuroplasticity, GPU stands out like the overall portrait of our ideal self, core traits, beliefs, and mission, whereas CPU the attitude towards daily practices that sustain that identity and lifestyle. In our previous example, think of GPU like confidence and CPU like the willingness to go introduce yourself to a stranger in a social setting. If we create our own dataset structure, our class must include 3 essential methods. Init, which establishes file paths for the data and annotations. We need a vivid imagination of how our new self could be and the practices and mindset we need to reach this image. Len, which returns the number of samples. How many areas we have to work on, and how many practices do we have to integrate to become our new self. Get item, which retrieves a single sample using an index, such as discomfort to talk to strangers when we think of the confidence we hope to reach. We then separate the dataset into X, the input features, the sketch we made of our new self, Y, the target labels, their response to various circumstances. The model must be able to switch between two distinct modes: training mode, or how we envisioned our new self in a situation. If we dream of parenthood, that could be standing by our kids' side as they discover the world. Evaluation mode, or how our new self would react in a particular situation, how we would respond to a conversation between a parent and a child we overhear on the train. This is where we describe the network architecture. We create a class that inherits from nn.module. Among the many model types available, some of the most common choices include 1. Sequential networks, basic stacked layers suitable for simple tasks like linear regression or basic classification. Just like us when we go through the habits we need to declutter. Would our new self still behave like this? If so, what impact would it bring to their life? 2. CNNS. Use local filters to detect shapes and textures, ideal for spatial data. In neuroplasticity, think of style, body language, and pre-verbal language. What grooming routine would my new self have? How do they walk? What's their tone of voice? How would our new self respond to criticism? 3. Transformers. Rely on self-attention. Exceptional in NLP, vision, and sequence modeling. Since Transformers stands out as a sequence-to-sequence pipeline, we aim for regulation, since we must feel safe for neuroplasticity to open, attaching a positive emotion to activities we chose, characterize our new self through, and repeat them till they become our new nature. 4. Autoencoders. Learn to compress and recreate data, useful for denoising and anomaly detection. Neuroplasticity isn't activated by obsessing over the outcome, but by engaging fully with the process. There's no other area in which fake it till you make it had more meaning. 5. JANs. Adversarial systems that generate images, styles, and realistic outputs. Think of the personal touches, features, or values you want to highlight and alchemize them into the personal branding your new self will go by. 6. GNNS. Operate on graphs. Powerful in social networks, chemistry, and recommendation systems. Think of the butterfly effect and how one micro-habit can impact unexpected areas of your life. When we make our bed as soon as we wake up in the morning, our mind registers starting the day with one task completed, activating a sense of achievement over other activities on our to-do list. Inside the model, we define layers, activation functions, learnable parameters. Activation functions give the model the ability to learn nonlinear patterns. Options include sigmoid, ideal for binary classification. Is this habit truly worth addressing, or does even my old identity remain untouched by it? Tan, zero-centered and helpful for RNNs. Do we really have too much on our plate, or our time management is actually affected by doom scrolling, binging series, and conversations excessively extended out of pure boredom? ReLU, efficient for deep architectures, by introducing sparsity and activating only some neurons. It's like when we decide to step out of our comfort, rather than just focus on what we love and what we want to enhance, while avoiding what scares us. Leaky ReLU avoids the zero gradient issue. Doing the uncomfortable doesn't just declutter tension, but also increases our self-esteem. GLU, smooth and used widely in transformers. How the impact of practices within one area is felt within others. We strike a conversation while queuing in the neighborhood we just moved, and all of a sudden we can do witty elevator pitches at networking events. Linear, used in regression outputs. Exactly like the strategy of initially picturing yourself within a role, if acting like your new self feels scary and unnatural to abruptly step into. The forward method lays out how data flows from the input layer to the output layer. Loss functions and optimizers. After initializing the model, we must measure error using a loss function. Examples include nn.mse loss for regression, where the goal is to predict a continuous value. Do we see our new self as an indefinite commitment or just an experiment? nen.ll loss for classification, or the repercussions a decisions might have beyond the area it was implemented. NN cross-entropy loss, combining log softmax and NLL, like the holistic impact of radical decisions like moving to another country. Next, we define how the model will learn via an optimizer. The optimizer receives parameters from model parameters, telling it which values to update. For example, the new you requires working on the people-pleasing tendencies. A learning rate, determining update size. How often do you come to the realization that the new you would not behave like that? And sometimes momentum, which depending on the optimizer type, helps speed up training and stabilize gradient descent by giving the optimizer a kind of memory of past updates. Just like in uncomfortable moments, we get the courage to further be recalling all challenges which used to scare us. A training step typically includes 1. Optimizer.0 grad clears previous gradients, exactly like habits or values we realized we outgrow the more we step out of our comfort zone. 2. Loss.backward computes the direction of parameter adjustments, exactly like pausing before reacting and adjusting our behavior to how our new self would respond. 3. Optimizer.step applies the updates, just like implementing the response which is most appropriate to our desired identity. Common optimizers include SGD, ideal for simpler tasks, like analyzing whether we're taking this particular habit or routine to our next chapter. SGD plus momentum, faster convergence, just like starting with the easiest to change activities. Atom, extremely popular for its adaptivity to sparse data, just like aiming an identity we don't quite properly understand, such as, for example, in entrepreneurship, the boring or tedious routine rather than the strategy. RMS prop, strong for volatile or non-stationary data, just like getting accustomed to patience for results which may not appear instantly. AdaGrad/Ada Delta, tailored for sparse features, such as building our new self for exceptional circumstances like relocating to another country. We often use TQDM to display real-time progress across epochs. Each epoch iterates through batches, computes metrics, performs backpropagation if needed, and then evaluates the model. To handle overfitting or instability, we use regularization such as dropout prevent overfitting by randomly deactivating a fraction of neurons during training. Slipping once doesn't mean we failed. Authenticity is given by a coherent, sustainable self, not performative perfection. Early stopping prevent overfitting by monitoring the model on a separate validation dataset during training and automatically halting the process when performance stops improving. We should aim not being appealed by a habit that doesn't serve us, rather than strongly rejecting it. Weight decay, restructuring models from overfitting when underparameterized or guide them towards simpler interpolations if overparameterized. Don't make a habit your entire identity. Love sports, but don't resume your life to just training. Training loop model.train activates the model's learning behavior. In this mode, dropout switches neurons off randomly. Batch norm uses statistics computed from each batch. A typical training iteration follows this sequence. 1. Activate training mode. 2. Reset gradients with optimizer.0 grad, like going through a day's review in which you congratulate yourself for each moment in which you broke a pattern or stepped out of your comfort zone. 3. Run the forward pass. Rewiring our brain to accept a new identity comes from small actions. 4. Compute loss between the difference between the actual target labels and the predictions. Exactly like in fitness, we may develop endurance in some exercises, yet others still challenge us. 5. Perform backpropagation. If we abruptly shed habits, we'll start perceiving the prospect of a new identity as overwhelming, So backpropagation is like readjusting the level to which we can get out of our comfort zone and not be discouraged by fear. 6. Update parameters with optimizer.step for the actual learning step where the model's weights and biases are refined. That impossible number of steps suddenly seems achievable, right? With TQDM, we can observe how metrics evolve at each step. During evaluation, we shift to model.eval. This freezes layers like dropout and batch norm. We also wrap inference in torch.nograd so that PyTorch doesn't compute gradients unnecessarily. Evaluation metrics include, for classification, accuracy, which measures the overall percentage of correct predictions. Am I able to see what habits I need to engage in? Precision, which measures the proportion of positive identifications that were actually correct. Should I try engage in this behavior just because I saw it promoted on social media as representative to my ideal self? Recall, or sensitivity, measures the ability of the model to find all the relevant cases. The difficulties to step into a new behavior are not linked to incapacity, but to the lack of custom. The F1 score is the harmonic mean of precision and recall, providing a single metric that balances both, especially useful for imbalanced datasets. For regression, root mean squared error, RMSE, gives more weight to large errors such as fully withdrawing from your social life until you consider to have stepped into your new identity. The mean absolute error, MAE, provides a linear average of error magnitudes. Think of how we self-sabotage through inconsistency when we promise we'll commit to building our new self. For computer vision, intersection over union calculates the overlap area between the predicted bounding box segmentation and the ground truth. Are we truly doing the work? Let's return to entrepreneurship, which is not only about strategy, pitches, and financial freedom, as it is about routine, risk-taking, and boring things. NLP, blue for translation quality. Exactly like the moments in which we fail to see the progress while focusing on the struggle. At this point, the model is prepared to produce predictions on fresh, unseen data. Is our identity consistent through new challenges? To conclude, dear friends, at the end of the day, all we need to do is train ourselves towards a growth identity opens up neuroplasticity, according to Carol Dweck. Lisa Feldman Barrett points out that our brain predicts our identity from past experiences. We don't react to the world, we react to your brain's predictions. Therefore, we'll manage to change our identity when we change the prediction. Giving our brain new inputs will create new context of meaning for the same experience. As pointed by Carol Dweck, even believing that we can change increases dopamine, motivation, neural growth, and resilience. Nevertheless, to fully step into our new identity, we have to prioritize training our brain to love the journey we just stepped into and attach a positive emotion to our new routine. We should always attach a positive emotion to every new activity. A positive outlook on the process stands out as one of the core pillars of neuroplasticity, alongside repetition and focused attention, according to Norman Doidge.